Welcome to the Electrical Safety General Awareness Training Module. This module will cover the following topics: Electrical Hazards Overview, Electrical Injuries including shocks, burns, electrocutions, and falls, Electrical Fires, Ground Fault Circuit Interrupters, Recognizing, Evaluating, and Controlling Electrical Hazards, Personal protective equipment, and OSHA requirements for working on electrical equipment. While on the job, there are many sources of potential electrical hazards. These include power tools, power lines, and electrical circuits. Not only electricians are exposed to electrical hazards, groundspeople, maintenance people, and other workers in the vicinity of electric hazards are frequently victims of electrical injuries. Just because you are not working on electrical circuits does not mean you are safe from electrocution. This training will provide general electrical safety awareness and education. An electric shock can be delivered anytime an electrical current passes through the body. This can happen through direct contact with an electrical circuit or through arcing as the electricity passes through the air. The injuries resulting from electrical shocks range from minor burns to electrocution and death. There are four main types of electrical injuries: electrical shock, burns, electrocution, and falls caused from shocks. The severity of an electrical injury depends on a couple of factors. These are the amount of electrical current flowing through the body and the length of time the current is conducted. Keep in mind that a typical home outlet can conduct 15 amps at 120 volts and that a typical nightlight operates at about 30 milliamps or 0.033 amps. The following are examples of the effects of different levels of current lasting 1 second at typical household voltages. 1 milliamp produces just a faint tingle. 5 milliamps produces a slight shock. 6 to 30 milliamps produces a painful shock. At this level, muscular control is lost, and it may not be possible to let go of the source of shock. 50 to 150 milliamps produces an extremely painful shock. At this level, breathing stops and severe muscle contractions occur. Death is possible. 1000 to 4300 milliamps produces ventricular fibrillation. This means that the heart is twitching and not pumping blood through the body. Nerve damage occurs and death is likely. 10,000 milliamps, or 10 amps, produces cardiac arrest and severe burns. At this level, death is probable. 15,000 milliamps, or 15 amps, is the lowest current that a typical fuse or circuit breaker will trip and open the circuit. In addition to the injuries listed above, loss of muscle control can cause falls or muscle spasms that produce further injuries, such as falling from a ladder or prolonging exposure to the electrical current. In addition to serious injury, defective or inappropriately used electrical equipment can produce heat, which can lead to electrical fires. Electrical fires are one of the most common sources of fires and burns at home and in the workplace. Small electrical fires can be extinguished by properly trained personnel using a fire extinguisher designed to put out Class C fires. All fire extinguishers are marked with the types of fires for which they are designed to be effective. Follow your facility's proper procedures when dealing with fires. A ground fault circuit interrupter, or GFCI, is a device designed to prevent electrical shocks. A GFCI operates by sensing the difference between the current in the supply and return conductors. Under normal conditions, these currents are equal. However, if a problem develops with the device you are using, electrical current can flow from your hand through your feet to the ground. The GFCI senses that the current in the supply conductor does not equal the current in the return conductor because some of the current is flowing through your body. The GFCI will trip and cut off electrical supply to prevent electrocution. A GFCI can sense current differences as small as 0.004 amps and trip in a very short time, 0.033 seconds. At that amount of time, you would receive a shock, but it would not cause serious injury. A typical 15 or 20 amp circuit breaker used in your power panel at home will not trip until the 15 or 20 amp levels are reached. Their purpose is to protect equipment and prevent fires and do not provide protection from electrocution. The best way to ensure electrical safety is to recognize, evaluate, and control hazards. This involves planning for the job to be done and taking steps to reduce and remove any potential electrical hazards. The next sections will discuss this safety plan in further detail. The first part of a safety plan is to recognize the electrical hazards you are about to face. You must know the situations that present danger. Exposed electrical parts or bad insulation can allow current to be passed from the normal circuit path to your body or other conductive material. Power tools and wires should be inspected before handling to ensure all electrical components are properly insulated. Overhead power lines can be dangerous when operating large equipment or moving large pieces of metal. Most overhead lines are not insulated and can immediately conduct electricity. You should always maintain at least 10 feet of clearance from overhead power lines or electrical lines. Overloaded circuits can create heat or cause arcing. It is possible that the circuit breaker or fuse will not trip and will not shut off the electrical current. This can lead to fires or burns. Wet conditions allow electricity to be conducted more easily, even through normally non-conductive materials such as wood or leather. Wet clothing, high humidity, and even perspiration can increase the potential for electrical hazards. After recognizing that electrical hazards exist, the next step is to evaluate the risks. Obviously, exposed electrical wiring is always a hazard. However, if the exposed wiring is up on the ceiling out of the way or at ground level near liquid chemicals, the risks are different. The following are clues that undetected electrical hazards are present. Tripped circuit breakers indicate that too much current is flowing through a circuit. Power tools or extension cords that feel warm may indicate too much current flowing through the equipment. A GFCI that trips indicates an imbalance in supply and return current. If any of these warning signs are present, you must evaluate the cause of the situation. After evaluating electrical hazards, you must take steps to reduce or remove the hazards. Actions may include changing equipment to better accommodate power needs, or reporting the observations to a supervisor. Whatever your facility calls for, do not ignore signs of electrical hazards. Sometimes taking corrective action might take longer than the actual job itself, but it is worth the time. You can never take too many precautions, as you never know when one might fail. Always test a circuit or wire before working on it to make sure it is de-energized. Lock out and tag out all involved circuits and machines. Prevent overloading a circuit or cord by using equipment with an appropriate rating. Prevent electrical shocks by using GFCIs. Work with another person that is properly trained for emergencies. Don't attempt any tasks for which you are not properly trained. In addition to these methods, you should always wear appropriate personal protective equipment or PPE for the job. There are many different types of PPE, but only some can protect you against electrical hazards. Different types of applicable PPE include gloves, insulated boots, face shields, safety glasses, and hard hats. Gloves can help prevent electrical current from entering your body through accidental contact to exposed wiring or electrical parts. There are different types of gloves, and you should choose the appropriate type for the work you are doing. Proper foot protection includes boots that are approved for electrical work. They should have an ANSI stamp of approval and be rated EH. ANSI rating alone does not guarantee electrical protection. Face shields help protect your face from flying objects or sparks. Goggles offer added protection to your eyes but will not protect your face. Hard hats protect your head from accidental bumps, falling objects, and from contacting unseen overhead wires. They should be worn securely so they do not fall off. In addition to wearing proper PPE, always remember to remove conductive personal items such as watch bands, bracelets, rings, keychains, or necklaces. OSHA has published the following restrictions in regard to working on electrical equipment. No employee will install, modify, or maintain any electrical device unless they are qualified and authorized. This includes all electrical power and control devices, lighting, computer network wiring installations, process control wiring at all levels, electrical alarm systems, heating, ventilating, and all wired communication systems. According to OSHA, Qualified persons must be trained in and familiar with the following: the skills and techniques necessary to identify exposed live parts of electric equipment, the skills and techniques necessary to determine the nominal voltage of exposed live parts. In addition, qualified electricians must be trained in and familiar with the following: the National Electrical Code, the National Electrical Safety Code, the voltage distribution system for the facility. If you do not meet these requirements, you are considered non-electrical personnel, and all restrictions that apply as such should be carefully followed. Electricity is essential in the workplace, but it is also dangerous. The need to constantly maintain, repair, and upgrade industrial equipment means that employees will be in close vicinity to high-voltage electricity. By understanding the dangers and following the proper procedures, these dangers can be virtually eliminated.